Hello there. So the first video was an overview of the whole project. From now on, we're going to look at each step of the project in turn. This first video will be on descriptive statistics and how it relates to your projects. In the first video, we started to look at descriptive statistics and the different tables that you'll need to include in your final projects. In this video, we'll look a little more deeply into some of those elements. But first, let's just step back a second and think about the different ways that we might use statistics in public administration. A little note, the word statistics comes from the word state, i.e. the public, the state, the public administration. Numbers were invented to count things, especially when you wanted to tax them. And today we use statistics in all walks of government life, from public safety. For example, CompStat is used by police to inform patrols, somewhat controversially. In the area of public health, we've seen a huge amount of data about the coronavirus outbreak and all the different elements of that. In education, we often use test scores, and a real challenge there is whether to judge schools and children by the scores that they receive, or whether we should look into more detail in terms of what's causing student performance, whether it's the school, whether it's the teachers, or whether it's the parents and their ability to provide education and other resources. And as you can see here, there's many different areas that we use data to inform our understanding of public administration. And we'll collect data across many different areas. We might think of data in terms of region or location being the unit of analysis, so maybe by city or by the region that we live in. We also think about variables in terms of demographics of people and the public. We also collect data on businesses, schools, organizations. Of course, there's lots of data wrapped up in budgets. And there's also many data in terms of specific categories, whether, for example, in public safety, we think of different crime types for police. One big area of data collection in recent years has been around officer-involved violence, and that really wasn't collected up until 2015. Since then, we've seen a lot of data collection that has informed some of the policy debates. So ultimately, data can be used, as long as it's used well, for informing policymakers about how to make better decisions and ultimately how to improve the welfare and livelihoods of all of our citizens. Now, data and statistics can often be controversial. In order to get around some of those controversies, we need to make sure that we're thinking critically about that data. To do that, we ask key questions. Where is the data gathered from? How is it measured and collected? You could have one data set which is really poorly measured and collected, measuring the same thing as another data set which is much more rigorous. You see that a lot in polls of election opinions. There's now many sites that have rankings of polling. They'll give one poll a A+ ranking, another a B, and another a C. And that really speaks to the variability in how data is collected. We also consider how should it be measured or collected. Often data isn't very well collected, and so we maybe can inform how it can be better collected. A good example there is homelessness data. A few years ago, the way in which it was collected and measured was changed, and that had an important impact on how policies have been made as a result. We also ask, what can it tell us? And what can it not tell us? Data is important, but it should not be the be-all and end-all. So I'd like to talk now about some different types of variables. This should cover what you worked on in 504, but I want to apply that now to why it matters in terms of multiple regression. One first type of data that I'd like to talk about is nominal data. Sometimes people confuse this thinking that it's a number. It's actually the opposite. It's not a number. It refers to name. The French word for name is nom. And here scores are only labels. They are not numbers. For example, you might have a data set which gives the respondent's religion, or maybe the city where they live, or maybe the school that they go to, or maybe the department that they work for. And all of these things could be recorded as names. Now, if you have data with names in them, obviously they need to be converted into numbers. However, even if you have a variable with different codes where the number represents a different name, for example, in religion, maybe Christianity is 1, Islam is 2, Judaism is 3, Buddhism is 4. Even if you have that kind of coding, you would still need to adjust your variables so that it could be used in a multiple regression. One way to do that is to convert the coded data into a dummy variable or a set of dummy variables. So for example, you could have Buddhist equaling 1 and all non-Buddhists equaling 0. This would be called a dummy, and we'll talk about this more in future classes. Multiple dummies can be used as independent variables, and you'd always drop one. If you're using a dummy as a dependent variable, then you need to use logistic regression. Again, look ahead in the course for more information on that. A second type of variable that is often used is an ordinal variable. Here, scores have some kind of numerical quality and they can be ranked. They can be put into order, ordinal. An example of this might be a Likert scale, which is what you often see on survey questions. For example, 1 might equal very satisfied, going through down to 5 might equal not satisfied or very unsatisfied. This could also include rankings. Often we might compare schools or countries in terms of their relative rank according to some kind of data. Now, these are okay to be used in multiple regression. For Likert scales in particular, it's best if you combine these into average groups of questions. It's also worth bearing in mind that interpretation can be tricky. For example, the direction of the coefficient is quite meaningful, but the size and magnitude often isn't. So please be careful with that. And finally, the type of data that we all hope you have, because this is the easiest to use, interval ratio. The scores are written as numbers, and those numbers are relative to each other in a usable interval that is consistent. So for example, this could be ages, it could be some kind of dollar amount, it could be the rates of a certain phenomenon in a population, or a ratio or percentage. It could be test scores. If you have these kind of data, you are good to go. Though it's worth bearing in mind that sometimes rates might need to be adjusted just to make more intuitive sense. So here again is another example of a descriptive statistics table. I've also included a hypotheses column in here. You can present it however you like. I'm sure you're all familiar with the concepts of mean and standard deviation. So here we have data on the percentage of a population with a high school degree or more for the year 2009 across each state. That's the dependent variable. And the average or mean percentage of the population with a high school degree for all the states is 86%. The standard deviation is 3.4%, which is a fairly tight cluster. So most states are within that 3% either side of the mean. In terms of hypotheses, we can see here some expected relationships that independent variables might have with the dependent variable. So for example, education spending is likely to have a positive relationship with the percentage of population with a high school degree. In other words, higher spending means more high school graduates. We'd also anticipate there to be a negative relationship between the number of poor people, in this case, percentage of families below the poverty line, and the percentage of population with a high school degree. So put in other words, as there are more poor people in each state, there would be fewer high school grads. And we undertake these hypotheses just to give ourselves something to compare against in our final evaluation. It's a bit like the hypothesis testing we did for the inferential statistics in 504. So the third element that we include in our papers is a correlation matrix. A correlation matrix tells us the relationship between pairs of variables, and you can see those represented here in this table. So for example, the relationship between always voting in elections and never trying to evade taxes is quite high. There are clearly some people who never evade taxes but still vote in an election, and vice versa, but the relationship is fairly strong. Now, if independent variables are highly correlated with one another, this can cause multicollinearity in your regressions. And there are further tests for this. If you identify this, then maybe you should drop one of the variables, or maybe you don't need to. There's debate around this. This will be in part 2 of the multiple regression video. So I hope this has been a helpful summary of descriptive statistics, especially as it applies to your projects. Please let me know if you have any questions.